Hello and welcome back to Physics Aid. In this video we will bring up the topic of work and energy, which a lot of people say to be the same thing, but in reality, energy is the ability to do work, while work is the change in energy. Here's a question. How do people become powerful? They work over time, because power is equal to work over time, and working over time. That was really bad. Let's move on. Most, if not all, work or energy problems will incorporate multiple units, since the equations of energy themselves are not challenging at all. Here's an example of a work/energy problem combined with dynamics, because these are pretty common. A 10-kilogram wagon moves horizontally at an initial speed of 5 meters per second squared. A 30-newton force is applied to the wagon by pulling the rigid handle, which is angled 60 degrees above the horizontal. The wagon continues to move horizontally for another 20 meters. A negligible amount of work is converted into thermal energy. By how much has the wagon's kinetic energy increased over the 20 meters? Since we're solving for the kinetic energy, let's bring up that equation. I'm going to go through and highlight every factor of the equations that we know, just to stay organized and focused on what we have to solve for, which I'll highlight in a different color. Since we're looking for the change in kinetic energy over the time period, we have to find the initial and final kinetic energy. We already know the initial velocity and the mass, so we can already calculate the initial kinetic energy. As for the final kinetic energy, we don't know the final velocity, so we're going to have to find a way to find that. The other thing that we know is that there are forces exerted on the wagon at an angle. With trigonometry, we can find the horizontal force acting on the wagon. We don't need to worry about friction in this problem because it says no energy is lost to heat. Therefore, we can determine that the horizontal force is the net force, since the wagon isn't accelerating in any other directions. And from the net force, we can find the acceleration, since we already know the mass. Once we know the acceleration, we can solve for the final velocity because we also know the distance traveled and the initial velocity. From there, we can just rearrange the equation and solve for the change in kinetic energy, which is 300 joules. The final derivation of the equations looks really intimidating, but trust me, doing it like this will save you a ton of time and make calculations much more easier and organized. In conclusion, for work and energy problems, there isn't much to say exclusively to the unit, but make sure you maintain the usual problem-solving skills, such as deriving equations and plugging everything in last. You'll often be faced with problems asking if a problem did work or gained or lost energy, so make sure you know the difference. You'll also be tested on the relationship between kinetic and potential energy in units, such as gravity, springs, and electrostatics, which is why I didn't cover that today. So anyway, thank you all for watching and see you all in the next video.